guys! Today, we are going to tackle about continuity of a function on an interval. But before we will discuss about this topic, let us first have a review on what is continuity. What comes out to your mind when you hear the word continuity? Because in mathematics, the term continuous has much more meaning as it does in everyday use. And to say that a function is continuous where x is equal to c, there must be no interruption in the graph of f at c. The graph of f must be unbroken at c, and there must be no holes, no jumps, or gaps. Consider the function that is shown below. So in this figure, this figure identifies the three values of x at which the function f is not continuous. First value, we have x is equal to c sub 1, f of c sub 1 is not defined. For the second value, at x that is equal to c sub 2, the limit of f of x as x approaches to c sub 2 does not exist. And for the third value, x is equal to c sub 3, f of c sub 3 is not equal to the limit of f of x as x approaches to c sub 3. At all other points in the interval of a, here, a, and b, the graph of f is uninterrupted, which implies that the function f is continuous at all other points of a and b. But in this figure here that is shown, we can conclude that f is not continuous when x is equal to c sub 1, c sub 2, and c sub 3. To further understand about continuity, help me read the statement for the next slide. So, let c be a number in the interval a and b, and let f be a function whose domain contains the interval a and b. The function f is continuous at the point c if the following conditions are true. So at this juncture, we are able to define whether a function is continuous. For the conditions that will be given, what do you think are those conditions? Oh, for the first condition, we have f of c is defined. For the second condition, the limit of f of x as x approaches to c does exist. And for the third condition, the limit of f of x as x approaches to c must be equal to f of c. If f is continuous at every point in the interval a and b, then it is continuous on an open interval. So, we already have here our two examples. Don't worry, I am here to help you and demo it to you. So for the first example, we have f of x that is equal to 1 over x squared plus 1. And for the second example, we have f of x that is equal to x squared minus 1 over x minus 1. Let's go back for the first example. The domain of f of x that is equal to 1 over x squared plus 1 consists of all real numbers, as you can see here in the graph. Yes, here. So, this function is continuous for the entire line. Then, we can conclude that it is continuous from negative infinity to positive infinity. Let's move now to our next example. f of x is equal to x squared minus 1 over x minus 1. Now, the domain of f of x that is equal to x squared minus 1 over x minus 1 consists of all real numbers except x that is equal to 1. So, this function is continuous on the intervals on negative infinity to 1 and 1 to positive infinity. The intervals being discussed for the examples 1 and 2 are open interval. To discuss about closed interval, help me read again the statement. Let f be defined on a closed interval a and b if f is continuous on the interval a and b, and the limit of f of x as x approaches to a positive and is equal to f of a, and the limit of f of x as x approaches to b negative will be equal to f of b. Then f is continuous on the closed interval a and b. Moreover, f is continuous from the right at a and continuous from the left at b. What we have here, another example. We will be having this first example. So, f of x is equal to square root of x. What do you think is the answer? Oh, it is continuous from 0 to positive infinity. Guys, for another fun fact, there is really difference between the two. What I mean is the brackets and the parentheses. The usage of bracket has meaning and the usage of parentheses also, and they are different. So, guys, browse about it for you to know more about these symbols. So, we have here to discuss the continuity of f of x that is equal to square root of 3 minus x. Notice that f is continuous from the left at x is equal to 3 because the limit of square root of 3 minus x as x approaches to 3 negative is equal to f of 3. And for all x that is less than 3, the function f satisfies the three conditions. The three conditions for continuity. So we can conclude there that f is continuous from negative infinity to positive 3. So that will be all for today. Thank you for watching. I hope that my video helped you in understanding the continuity of a function on an interval. See ya!